24 billion kilometers from Earth, moving through a region of space no human-made object had ever reached before. A 48-year-old spacecraft with a fraction of the computing power of a modern calculator detected something in 2020 that should not have happened. And 5 years later, in a paper published in May 2026, scientists confirmed it still hasn't gone away. This is Voyager 1. Launched in 1977 to fly past Jupiter and Saturn, it kept going long after its mission ended, and in 2012 it became the first human-made object to cross the heliopause, the boundary where the sun's influence ends and true interstellar space begins. It is now the most distant object humanity has ever built, and what it has been sending back from out there doesn't match what physics predicted it would find. When Voyager 1 crossed into interstellar space, scientists had a model for what that transition should look like. The heliosphere, the vast bubble of solar wind and magnetic field that surrounds our entire solar system, was expected to end at a relatively clean boundary, beyond which Voyager would find the calm, sparse plasma of true interstellar space. In April 2013, instruments confirmed the crossing had actually happened. The plasma around the spacecraft was suddenly 40 times denser than anything measured inside the heliosphere. The density jump was exactly what the models predicted. That part worked. The magnetic field did not. Once outside the heliopause, Voyager 1's magnetometer measured a magnetic field consistently stronger than any value scientists had predicted for that region, persistently above 0.4 nanotesla, a value considerably higher than models of the local interstellar medium anticipated. And it wasn't just the strength that didn't fit. The direction was wrong too. Voyager 1's measurement of the interstellar magnetic field's orientation came out more than 40 degrees off from independent measurements taken by other instruments studying the same region from a completely different method. Two different ways of measuring the same thing in the same place, producing answers that didn't agree by a margin far too large to be instrument error. Scientists proposed an explanation in 2015 that Voyager 1 was passing through a more distorted, turbulent patch of magnetic field just outside the heliopause, and that eventually, given enough distance, the spacecraft would reach a calmer, more representative region. They predicted it would take about 10 years. That was 10 years ago. Then in 2020, something happened that the existing framework couldn't absorb. Voyager 1's magnetometer registered an abrupt jump in the strength of the magnetic field, and simultaneously its plasma detector measured a corresponding rise in plasma density. This wasn't unprecedented on its own. Voyager had recorded similar transient spikes before, interpreted as pressure waves generated when bursts of solar wind slam into the outer edge of the heliosphere, sending a shock rippling outward through interstellar space like a piston pushing a wave ahead of it. Every previous event like this had faded back to baseline within a few months, exactly as that model predicted. The 2020 event did not fade. Years passed. The elevated magnetic field readings stayed elevated. This was the fourth distinct magnetic structure Voyager 1 had now detected in interstellar space since 2012. But unlike the three before it, this one simply never resolved back to the pre-event baseline. NASA Goddard astrophysicist Szabo, the magnetometer's principal investigator, described the standard piston explanation for these events, and then acknowledged the specific problem this one presented. The anomaly that began in 2020 did not abate, which led mission scientists to question whether it originated with the sun at all. That sentence is doing enormous work. For every prior anomaly, the explanation was solar, something our own star did, rippling outward, eventually fading. This one raised the possibility that Voyager 1 might not be detecting an echo of home. It might be detecting a genuine, permanent feature of the structure of interstellar space itself. Something that has nothing to do with the sun, and that our models never accounted for because no instrument had ever traveled far enough to find it. In May 2026, a team of researchers led by Jiwoo Park at NASA Goddard, using continuous Voyager 1 data collected from 2020 through mid-2025, confirmed the anomaly with 5 additional years of observation. Their conclusion: the magnetic field environment in the region beyond the 2020 event remains remarkably distinct from the region that came before it. Not a temporary spike that eventually faded, a lasting, measurable, structural difference in the magnetic character of the space Voyager 1 is now traveling through, one that has persisted continuously for more than half a decade. There is a separate, equally strange thread running alongside this. Between 2017 and 2020, Voyager 1's plasma wave instrument detected something researchers hadn't anticipated at all: persistent plasma waves. Not the occasional violent bursts triggered by solar shocks reaching the boundary. A continuous, low-level hum of activity in a region of space that models had described as close to silent. Scientists studying the data found a new narrowband signal spanning the entire multi-year period, a signature nobody had predicted would exist out there, indicating that interstellar space, at least in the region Voyager 1 is passing through, is far more dynamically active than the calm, empty picture scientists had constructed before any spacecraft ever measured it directly. None of this means Voyager 1 has encountered anything artificial, or anything that violates the laws of physics. It means something more interesting than that. It means the actual structure of interstellar space. The density of its plasma, the strength and orientation of its magnetic field, the frequency and duration of activity within it, does not match the model scientists built using theory and indirect observation. Before any instrument had physically traveled far enough to check. That is the real story here, and it doesn't need embellishment to be remarkable. For decades, everything we knew about the region just beyond our solar system was inference, extrapolated from telescopes, from cosmic ray measurements taken from Earth, from theoretical models of how plasma and magnetic fields should behave at that distance. Voyager 1 is the first and only instrument that has ever actually been there to check, and every time it checks, the numbers come back different from what the models said they should be. The spacecraft is powered by a radioisotope generator that produces less electricity every year, transmitting data through an antenna the size of a dinner plate, using a computer with less processing power than a musical greeting card, from a distance so vast that its signal, traveling at the speed of light, takes over 23 hours to reach Earth. And it is still teaching physicists that they don't fully understand the space directly outside their own front door.